Welcome to ASquare Maths by A2 E2, Session 2 of Laplace Transform. Brihu. In previous section, we saw Laplace transform of some standard functions. We saw Laplace transform of 1 is equals to 1 by s, Laplace transform of k, where k is constant, is equals to k by s. Laplace transform of t raised to n is equals to gamma n plus 1 upon s raised to n plus 1 for s is greater than 0 and for all real numbers n such that gamma of n plus 1 exists. Laplace transform of e raised to at is equals to 1 upon s minus a for s is greater than a. Then we saw Laplace transform of sine of at is equals to a upon s square plus a square for s greater than 0. Laplace transform of cos of at is equals to s upon s square plus a square for s is greater than 0. After this, we saw Laplace transform of hyperbolic sine and cosine. Laplace transform of hyperbolic sine of at is equals to a upon s square minus a square for s is greater than mod of a. And last, we saw Laplace transform of hyperbolic cos of at is equals to s upon s square minus a square for s greater than mod of a. We saw all these Laplace transform of some standard functions with proofs. Let us see some basic examples to get the clear picture of this all the standard formulas. First, Laplace transform of a, where a is a constant, is equals to 1 by a. Next one, let us find the Laplace transform of t raised to phi. Therefore, Laplace transform of t raised to phi is equals to gamma phi plus 1 upon s raised to phi plus 1, since Laplace transform of t raised to n is equals to gamma n plus 1 s raised to n plus 1. Hence, gamma phi plus 1 is nothing but gamma 6. Since it is an integer, gamma 6 is equals to 5 factorial upon s raised to 6. And the value of 5 factorial is 120 by s raised to 6. Next, we saw Laplace transform of e raised to at is equals to 1 upon s minus a. For the sake of understanding, I have taken one sum here. Laplace transform of e raised to 4t is equals to 1 upon s minus 4. Similarly, for sine and cosine of Laplace, Laplace transform of sine of 3t is given by 3 upon s square plus 3 raised to 2. That is, by using Laplace transform of sine of at is equals to a upon s square plus a square. And Laplace transform of cos of 70 is equals to s upon s square plus 7 square. Since Laplace transform of cos of at is equals to s upon s square plus a square. Hence, 3 square can be replaced by 9 and 7 square can be replaced by 49, and you get the Laplace transform of sine of 3t and cos of 70. Next, Laplace transform of hyperbolic sine 9t is equals to 9 upon s square minus 9 square, and it is by the formula Laplace transform of hyperbolic sine of at is equals to a upon s square minus a square. And similarly, Laplace transform of hyperbolic cos of 3t is equals to s upon s square minus 3 square can be written as s upon s square minus 9. Similarly, 9 square can be written as 81. These are all basic examples which I have given for the better understanding of the Laplace transform of the standard functions. Let us see some basic properties of the Laplace transform. First shifting property. Statement. F of t be a function of t and Laplace transform of f of t is equals to f bar of s, then Laplace transform of e raised to at f of t is f bar of s minus a. By definition of Laplace transform of f of t is given by integration from 0 to infinity e raised to minus st f of t dt. Let us replace f of t by e raised to at f of t on both the sides. Then by the law of indices e to the power minus st and e raised to power at, since basis sum can be written as e raised to minus st plus at. After this, whatever the powers can be written as minus s in the bracket s minus a into t. If you observe s minus a, you can take as a parameter of the frequency domain, and it is nothing but the Laplace transform of f of t with the parameter s minus a, and it is nothing but the f bar of s minus a by definition of the Laplace transform. Hence, Laplace transform e raised to at f of t is equals to f bar of s minus a. Let us see example. Find Laplace transform of e raised to minus 4t cos of 3t. Let f of t is equals to cos of 3t. Therefore, Laplace transform of f of t is equals to Laplace transform of cos of 3t, that is equals to s upon s square plus 3 square. And therefore, Laplace transform of f of t is equals to s upon s square plus 9. 3 square can be written as 9. Since cos of Laplace transform of cos of at is nothing but s square plus s square. By first shifting property, you may replace Laplace transform of e to the power minus 4t cos of 3t is equals to s plus 4 upon s plus 4 the whole square plus 9. That is, if the function is multiple of e raised to minus 4t, directly whatever the Laplace transform of cos of 3t, there s will be replaced by s plus 4, and that nothing but the first shifting property. Sum number 2. Find Laplace transform of t to the power 5 hyperbolic cos of 70. Here we have t to the power 5 and hyperbolic cos of 70. We don't have direct formula, but whatever the hyperbolic cosine of 70, you can transform it into exponential form, and you may use the first shifting property. So that let us start from t to the power 5 hyperbolic cos of 70. Whatever the hyperbolic cos of 70 can be written as e raised to 70 plus e raised to minus 70 by 2. 1 by 2 you can take outside, e to the power 70 t to the power 5 plus e to the power minus 70 t to the power 5. Let f of t is equals to t to the power 5. Therefore, Laplace transform of f of t is equals to Laplace transform of t to the power 5 is equals to gamma 5 plus 1 divided by s to the power 5 plus 1. By using Laplace transform of t to the power n is nothing but gamma n plus 1 upon s raised to n plus 1, provided that n is a real number of which gamma n plus 1 exists. And therefore, Laplace transform of f of t is equals to 5 factorial upon s raised to 6. Therefore, Laplace transform 1 by 2 in the bracket e to the power 70 t to the power 5 plus e to the power 7 minus 70 t to the power 5 is equals to, by linearity property of Laplace transform can be written as 1 by 2 in the bracket Laplace transform of e to the power 70 t to the power 5 plus Laplace transform of e to the power minus 70 t to the power 5. As we have the Laplace transform of t to the power 5 here, in that Laplace transform, by using first shifting property, s will be replaced by, in the first Laplace, s minus 7, and in the second Laplace transform, s will be replaced by s plus 7. Hence, Laplace transform of t to the power 5 hyperbolic cos of 70 is equals to 1 by 2, as it is 5 factorial upon s minus 7 to the power 6 plus 5 factorial upon s plus 7 to the power 6. by first shifting property. I use here first shifting property and statement of first shifting property already we have done. If f of t be a function of t and Laplace transform of f of t is equals to f bar of s, then Laplace transform of e to the power at f of t is equals to f bar of s minus a. Here in the first case a is 7 and in second case a is minus 7. Hence in the first case s is replaced by s minus 7 and in the second case s is replaced by s plus 7. Hence the answer. Let us take the second property, second shifting property. If f of t be a function of t and Laplace transform of f of t is equals to f bar of s, and let us define a function g of t such that g of t is equals to f of t minus a for all t greater than a and 0 for all t less than or equal to a. That is, up to 0 to a, the function of g of t is 0 and the function g of t has the value for all values of t which are greater than a is f of t minus a. Then Laplace transform of g of t is equals to e to the power minus as f bar of s. Let us see proof of this theorem or property. Let us start from the definition of the Laplace transform. By definition of Laplace transform of g of t is equals to integration from 0 to infinity e to the power minus st g of t. Let us, since the value of g of t has been given in two intervals, then this integral will be splitted from 0 to a, for which g of t will be replaced by 0, and from a to infinity, this value of g of t will be replaced by f of t minus a. So Laplace transform of g of t is equals to integration from 0 to a e raised to minus st 0 dt plus integration from a to infinity e raised to minus st f of t minus a dt. Therefore, integration of 0 is 0, so this term will become meaningless. Let us have only one term here. Integration from a to infinity e to the power minus st f of t minus a dt. Let us put t minus a is equals to u, therefore dt is equals to du and t is equals to u plus a. As t varies from a to infinity, for t is equals to a, u is equals to 0, and for t is equals to infinity, u is equals to infinity. By putting the integrals in terms of u, you will get here integration from 0 to infinity e to the power minus s u plus a, t will be replaced by u plus a f of u du. But if you observe this e to the power minus s u plus a, here e to the power minus s a is constant term as far as integration with respect to u concerned. So e to the power minus as you can take outside, integration from 0 to infinity e to the power minus s u f of u du. And hence by definition of Laplace transform, this term is nothing but the f bar of s, where s is the frequency domain. Hence a Laplace transform of g of t is equals to e to the power a is equals to t minus 3 raised to 4 for if t is greater than 3 and 0 if t is less than or equal to 3. Here if you observe, here g of t has point of discontinuity at 3. So t to the power, here you can take f of t is equals to t to the power 4 and a is equals to 3. By the second shifting property, we have defined g of t is equals to f of t minus a. Hence here f of t minus a is nothing but t minus 3 raised to 4. Therefore f of t is equals to t raised to 4. Let us find the Laplace transform of t raised to 4, and it is nothing but the Laplace transform of f of t is equals to Laplace transform of t raised to 4 is equals to gamma 4 plus 1 upon s raised to 4 plus 1, and this can be 4 factorial upon s raised to 5. And therefore by second shifting property, Laplace transform of g of t by using this formula e raised to minus 3s, because here a is equals to 3, 4 factorial upon s raised to 5. It is the required answer of this problem. Next property, change of scale property. If f of t be a function of t and Laplace transform of f of t is equals to a bar of s, then Laplace transform of f of at is equals to 1 upon a f bar of s by a. Let us see proof of this change of scale property. By definition of Laplace transform of f of t is equals to integration from 0 to infinity e raised to minus st f of t dt. Let us replace f of t by f of at since we want to find the Laplace transform of f of at. So Laplace transform of f of at is equals to integration from 0 to infinity e raised to minus st f of at dt. To simplify this integral, let us put at is equals to 0. Therefore, a dt is equals to du and t is equals to u by a. As t varies, u will vary. T varies from 0 to infinity. U will vary. For t is equals to 0, u is equals to 0. And for t is equals to infinity, u is equals to infinity. Hence, by replacing entire integral in terms of u, we will get integration from 0 to infinity e to the power minus s u by a f of u du by a. As far as integration with respect to u concerns and a is a constant 1 by a, we can take outside, and little bit change we can do in the power of e to the power minus s by a u f of u du. By definition of Laplace transform, we can take s by a as a parameter, and it is nothing but the definition of the Laplace transform, and it is nothing but the f bar of s by a. And hence we can prove that Laplace transform of f of at is equals to 1 upon a f bar of s by a. Let us take one sum on this property. If Laplace transform of f of t is equals to s plus 2 upon s cube plus 2s square plus 4s minus 5, find Laplace transform of e raised to minus 2t f of phi t. I'll start what we have given. Let Laplace transform of f of t is equals to s plus 2 s cube plus 2s square plus 4s minus 5. Hence, by first shifting property, we want to find the Laplace transform of f of phi t, that is, instead of a, we want to replace a by 5. So, change of scale property, by using change of scale property here, Laplace transform of f of at is equals to 1 upon a f bar of s by a. Hence, 1 by a, that is 1 by 5, and all s in this equation will be replaced by s by 5. So, s by 5 plus 2 s by 5 raised to 3 plus 2 s by 5 raised to 2 plus 4 s by 5 minus 5. Then Laplace transform of e raised to minus 2t f of phi t. Here we found Laplace transform of f of phi t. Now we want to find the Laplace transform of e to the power minus 2t f of phi t. That is, here exponential function is multiple of f of phi t. So here you are supposed to use the first shifting property, and by using first shifting property, whatever the s in f bar of s will be replaced by s minus a. Here s is equals to minus 2. Hence s will be replaced by s plus 2. Hence Laplace transform of e raised to minus 2t f of phi t will be equals to 1 by 5 as it is, s plus 2 by 5 plus 2, s plus 2 by 5 raised to 3 plus 2, s plus 2 by 5 raised to 2 plus 4, s plus 2 by 5 and minus 5 as it is. To be continued to the next section. Thank you.